Okay, I'm actually going to go over the do now in the video today, which is a little bit different. So if you're kind of stuck on this, I asked you for the greatest common factor. So it's like, what's the biggest number I can divide into both numbers? So here, 2 is the biggest number I can divide into them. I need to think about their factors, right? You can make a list, you could do all kinds of things. We used Euclid's algorithm earlier this year to figure this out. So here I think 2 is my biggest factor. Sometimes you can make a list if you're not sure. Over here, let's look at 18 and 24. 18 and 24, well, I know 18 can be divided by 2, by 9, by 3, by 6. And then I also know it can do 18 and 1. 24, I know it can do 2 and 12. I know 3 and 8. I know 4 and 6. And I think that's about it. Well, obviously 24 and 1. But I said greatest common factor. So in common, 2's, yes. But not the greatest one. The greatest one they share is 6. 6 is the biggest one that can go into both 18 and 24. So if you're a little tripped up, I encourage you to pause the video and try to go find a few more of these. So let's look here first. So I'm going to think, what's the biggest number that I can divide into, the greatest factor of both of these? Well, I know 5 can go into 15 because 5 times 3 is 15. I also know 5 times 7 is 35. So here, the largest factor, the greatest common factor of 15 and 35 is 5. 7 doesn't go into 15, but 5 goes into both of them. Well, the next one, this one's pretty easy. 2 can go into both of these numbers. I can divide both of them by 2, but I can also divide both of them by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So here I'm going to say 4 is my greatest common factor. Now I'm going to keep going. Here, 15 and 45, oh, let's see, they both end in 5, so it means they can be divided by 5. But think about a clock. This is a quarter of an hour, this is 3/4 of an hour. I can actually divide both of those numbers by 15. That one was a little bit more challenging. Let's keep going on ahead. We have 20 and 50. Oh man, this one doesn't seem too bad. It actually isn't. I can divide both of these by 10 because they end in 0. And I can't go any higher than that. So 10 is the greatest common factor, the greatest number that can divide into both numbers. For my next one, let's see. Well, I know 24 and 36. Well, they both share 2. Both can be divided by 2. Both can be divided by 4 because I'd get 6 or 9. I can divide both by 6 because if I divide 24 by 6, I get 4. If I divide 36 by 6, I get 6. 8 doesn't work. 8 goes into 24, but not 36. What about 12? 12 goes into 24 twice, and 36 3 times. I think that's probably going to be it. That's going to be our greatest common factor here, 12. And then finally on this last one, 75 and 50. Think about money. Think about money. Yes, both of them can be divided by 5, but I can also divide both by 25. 25 fits into 50 twice, and 75 3 times. So we're going to be looking at this thing called the distributive property. We're going to do it from an area model today. So I've started by showing 10 plus 6 in this rectangular form. We're going to try to write it in factored form. Right now it's in expanded form. We're going to try to get it written in factored form. So I'm going to think, what number can I divide into both 10 and 6? Well, I can divide 10 by 2. I can also divide 6 by 2. So I might think this side is 2. Now if I do that, this would have to be what? 2 times what gives me 10? 2 times 5 gives me 10. And I think the same thing with 6. 2 times what gives me 6? And of course my answer would be 2 times 3 gives me 6. So I can think of these as being added together, and 2 is multiplying both of them. So I can say 2, this is the same thing as 2 times 5 plus 2 times 3. Or we expand it out like this. We just say 2 times whatever 5 plus 3 is. So again, I think of this right here. I think of that as 2 times 5 plus 3. When it's just sitting next to it, that's that adjacent multiplication we talked about yesterday. So let's try this next one. So again, we're going to use an area model here. I know I've got 2a plus 2b. No, that's not 2b, 2b. And what do they share in common? They both share 2's. So I can divide a 2 out just like I could divide a 2 out of there. So I divide a 2 out, and 2 times what gives you 2a? Well, 2 times a gives you 2a. 2 times what gives you 2b? 2 times b gives you 2b. So what I have here is I have 2 times a plus 2 times b, which in its factored form, I can just factor that 2 out. I'm going to multiply it by, I'm going to multiply a plus b. I'm going to multiply that by 2, just like I did up here. All right, let's take a look at one more. If you think you can figure out 6x, if you think you can figure out 6x plus 9y, I encourage you to pause and try that out. Otherwise, I'm going to keep moving on. But I would really encourage you. I think you can do it. Try to pause. Try to find the common number, divide out. Try to write it in factored form, and then come back as soon as you think you got it. All right, so again, I'm asking myself, what can I divide both 6 and 9 by? Can I put 6 here? 6 fits into 6, but it doesn't fit into 9 2 whole times. It only fits in like 1.5 times. So I can only say 3. And so 3 times what will give me 6x? You might say 3 times 2 gives you 6, but I also need to have an x there. So I'm going to say 3 times 2x. Then here, 3 times what gives me 9y? Well, 3 times 3 gives me 9, but I also want there to be a y there. So I need to make sure that a y comes in right here. So what do I have? I have 3 times 2x plus 3 times 3y. And of course, what is this equal to in the factored form? 3 times the quantity 2x plus 3y. 2x plus 3y. So it's almost like this thing, this outside number, is getting multiplied by this stuff when it's in parentheses. Of course, when they're pushed together, we know they're being added. All right, let's keep pushing forward here. I know those are some confusing models. Let's see what we can do. So let's take a look at this slightly different version. So first, make a table here. We're going to write what we have in expanded form, and then we're going to show it in factored form. This is the same examples we just went over with the area model. So here I can think of this. I can push these two together. Remember, we can add in whatever order we want. So I'm going to rearrange things so that my 5s are next to each other. So 5, 5, 3, and 3. So now my expanded form tells me that I have 10 plus 6. So I have 10 plus 6. But in its factored form, what we have are two groups of 5 plus 3. So how am I going to show two groups of 5 plus 3? Like this, two groups of 5 plus 3. So two groups of 5 and 3. We know the word groups makes us think multiplication and division. So that's what I'm thinking there. 2 times these groups of 5 and 3. Let's see if we can rearrange this one. So again, I'm going to rearrange the stuff that I like together. So I'm going to rearrange A's. So the A's are next to each other, and the B's are next to each other. So I'm going to move A right over here. Here we go. I've got my A's. They're still roughly the same size. I've got my B's right here. And again, I can rearrange them because we know we can add in whatever order we want. So now I don't just have 2A, I have 2 A's and I can write 2A, and I have 2 B's and I can write 2B. So here, this means I have 2A plus 2B. Or I have two groups of A and B. Two groups of A and B. That's what it means. Just like we have up there. Two groups of 5 and 3, we just change the numbers. Two groups of A and B. So with variables, we don't think of it any differently. So let's see if we can now do this no models. No models whatsoever. So here is 12 plus 8. Again, I'm thinking, what can 12 and 8 be divided by? So I'm thinking 12 and 8. What's the biggest number 12 plus 8 can be divided by? I'm going to write over here so I have a little more space. 12 plus 8. The biggest number this can be divided by is 4. In a way that you can help think about this, I'm actually going to add one more layer of work here. Gosh, if you're erasing a lot, I'm really sorry. I should have planned a little better here. So 12 plus 8. I'm actually going to expand these out. I'm going to think, well, 12, I can write that as 4 times 3. And 8 I can write as 4 times 2. So my common number that I can factor out is 4. I can say four groups of 3 and 2. 4 groups of 3 and 2. This is what I call my factored form. My factored form. So now go see if you can try this one on your own, just 24 and 30. See if you can write that in expanded form and come back in about 30 seconds. Then we're going to try the variable ones. Okay, hopefully you're back from this. So here I'm going to say, okay, 24, I can break that down. What can I divide both by? I can divide both 24 and 30 by 6. So I can say 6 times 4, and I can say 6 times 5. 6 times 4 and 6 times 5. So the number, I have 6 groups of 4 plus 5. I just factor my 6 out of both terms. All right, let's take a look at a variable one. Let's try this one right here. So here I'm asking myself, well, what's the common factor? I actually think the variable ones can be a little easier sometimes. The common factor this time, it's kind of weird. It's actually C. I have C groups. What's common? They're both multiplied by C. So I'm going to say this is the same thing if I factored out as C times 311. C groups of 3 and 11 added together. All right, let's try another one here. So here, 7x and 7y, I can write it as 7 times x plus 7 times y. What factor do they share? They share a 7. So I can say this is 7 groups of, think about what goes on the inside, see if you can figure it out before I say it, x and y. Last one. Pause if you want to, take 30 seconds to figure it out, otherwise I'm going to go on and go ahead. I know this can be 2 times k plus 11 times k. What's their common factor? What do they share? They both share a k. So I can factor it out, and I can write k groups of 2 and 11. K groups of 2 and 11. So if you missed anything in that video, go back, rewatch, and see what you can do.